Let's look at experimental and theoretical probability. Now, both of these are forms of probability, which means it's some possible number of ways, or some number of ways we're looking for over the number of possible ways. Theoretical probability, if we're looking at something like a coin where you have on one side heads and on the other side you have tails. Let's draw a little eagle on the back here. So on one side head, one side's tails. Theoretically, you have a 1 out of 2 chance of getting heads because there's 2 possible outcomes. One of them is heads, so 1 out of 2 in theory is the probability of getting heads. Now, the way that you would test that is by actually flipping a coin. And let's say that I flip a coin and I get heads. And then I flip it again and I get heads again. And then I flip it and get tails. Get heads and get tails. And then I stop. So I did it 5 times. My experiment, by actually flipping the coin, it looks like I have 1, 2, 3 heads out of 1, 2, 3, 4, 5 flips. So my experimental probability was 3 out of 5. But the thing about experimental probability is that you can do it as many times as you want for as many times as you want to. I could do an experiment and do it only twice and get tails and tails. And then my probability would be 0 out of 2. Or, if I'm feeling ambitious, I could flip it a whole bunch of times. I could do heads, heads, tails, heads, 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 tail, whatever. And let's see how many I got. I have 1, 2, 3, 4, 5, 6, 7 heads out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 7 out of 16 heads. And so the idea with experimental probability is that it is not any single number. It just depends on running an experiment. You have to try it and see what you get. So every time you run the experiment, it might be a little bit different. The theoretical probability is never going to change. This is what it is every single time. It will never change because it's based in theory. You have 2 outcomes. They have the same chance of happening. 1 out of 2. 1/2. Now, another thing that happens with experimental probability is that you can get some crazy values. Like when we tried it twice and we got tails, tails, that's 0 out of 2. That is nowhere close to a 50% chance, a 1/2. 0 out of 2, 0% chance doesn't even make sense, given that every coin has a tail side. So what you need to do with something like that is keep flipping the coin, because eventually you're likely to get it to balance out a little bit. So let's say you flip it again. You're still 0 out of 3. And this could happen where you could get a bunch of tails in a row. But eventually you'll probably start to get a head or 2. Maybe a couple heads in a row. Maybe a tails mixed in. And the whole point is this, is that if you flip the coin once, you're either 100% heads or 100% tails. If you flip it twice, there's still a pretty good chance of getting 0 heads or 2 heads. 1 out of 2 is not all that likely to happen. It's surely not guaranteed, at least. And so the idea is that things can be very chaotic early on with your experimental probability. But the more and more and more you flip it, eventually it starts to kind of even out. It starts to even out. So if your probability goes from 100% chance up here, 100% chance, or a probability of 1, down to a 0% chance, or a probability of 0, down here, and 50-50 in the middle, so 50% chance or 0.5 probability. Over time, the more you flip it, the more that your actual experimental probability is going to kind of land pretty close to the theory. So if you flip the coin a bunch, it should, over time, even out. Not guaranteed to, but it's very, very likely to. And that is something called the law of large numbers. Because if you roll that die or flip that coin a large number of times, eventually it's probably going to behave as expected. That's why a casino, where people are gambling all day, is comfortable that they are always going to win in the end. Some people might come away winning a lot of money and other people might lose money, but they know in the long run all of their games are set so that the casino will win about 5% of everyone's money, guaranteed in the long run. That's why running a casino where it's so much up and down is okay, because they know in the long run they're going to make their money. The law of large numbers.